Today, we're going to take a look at the special triangles 30, 60, 90, and 45, 45, 90 that allow you to find all the sides of a triangle if you have been given a single side of a triangle. Let's take a look. All right, so let's say you've been given a triangle and you're told it's a right triangle, and then you're told that this angle right here is 60 degrees. Well, first of all, if you have 90 and you have 60, then you know this by just going 180 minus 90 minus 60. So therefore, we have a 30-degree angle, and this is your 30, 60, 90 triangle. That's what it means. It means that the three angles are 30, 60, and 90. All right. So there's a formula that lets you, with a single side, find the other two sides, right? Normally, with Pythagorean theorem, we need two sides to find the third side. Here we go. The side opposite the 30 is going to be the smallest side in the triangle, and let's call that x. We know it's the smallest side because the smallest side's opposite the smallest angle, the biggest side is opposite the biggest angle, and the medium side's opposite the medium angle. So if our smallest side is x, then in the 30, 60, 90, our hypotenuse, the one opposite the 90, will be twice that. It will be 2x. And the side opposite the 60 will be x root 3. Let's take 1 second just to talk about what opposite means. Sometimes students have trouble seeing it. It means the side not involved in making that angle, but rather the one directly across from it. So 2x is opposite 90. X is opposite 30, right? It's not involved in the making of that 30-degree angle. And x root 3 is opposite 60. It's not involved in the making of that 60. Okay, great. Now we have our terms. So now, how do we use this? So let's say that we're given that the hypotenuse of our 30, 60, 90 triangle is 18. So I check with my formula and I see that 18 is in the 2x position. So I'm going to write the following. 18 equals 2x, and then I'm going to solve for x. So x equals 9, and now I go back to my formula. This side here is x, so that means it's 9. And this side here is x root 3, so that means it's 9 square root of 3. And if you want to geek out, go ahead and apply the Pythagorean theorem to this and show yourself that it works. And if you truly want to geek out, go ahead and apply Pythagorean theorem to this and see that the formula works. Okay, now what happens if we're not given the x or the 2x side, but we're given the x root 3 side? Let's take a look. So let's say instead we're given that the side opposite 60 is 7, and you're like, I don't know what to do with that. Here's what to do with it. Same thing, set it equal to x root 3 and solve. So that would look like this. Okay, 7 equals x root 3. We want the x by itself, so that means opposite operations. We divide both sides by root 3. So 7 over root 3 equals x. And we know we can't have a root on the bottom. If you don't know that, then go ahead and click this link and take a look at my video on rationalizing your denominator. But otherwise, we do what? Yep, that's right. We multiply top and bottom by root 3. That takes the root 3 in the bottom and makes it just 3. And then 7 times root 3 is 7 root 3. So now we have our x. Well, that's this side right here. And we know that this side is 2 times x. So that makes it pretty? No. Doable? Absolutely. So when you are doing a 30, 60, 90 problem, the first thing you should do is write this on the page to help you keep track of what to do with the various numbers they give you. Let's take a look at it again for the 45, 45, 90 triangle. All right, the 45, 45, 90, otherwise known as the isosceles right triangle. So here are our ratios. If the sides opposite the 45-degree angles are both x, and we know they'd both be the same thing because sides opposite equal angles are equal, then the side opposite the 90 equals x root 2. All right, let's put this into practice with some numbers. So let's say you're given this problem and you're asked to find the remaining two sides. All right, so our 6 is in the x position, which makes life really easy. That means this guy, also 6, and this guy, 6 root 2, easy peasy. Now, let's take a look if we're given the root 2 position. Let's say we're told that our hypotenuse is 27. Thanks a bunch, teach. No problem. 27 is x root 2. So set it up that way and solve. All right, what do? That's right, divide both sides by root 2. What's that thing called when a root 2 is in the bottom? That's right, rationalizing. Let's do it. Multiply top and bottom by root 2. That leaves us with 2 on the bottom and 27 root 2 on the top equaling x. Again, pretty? No. Doable? 100%. Now, here's a little hack to remember which special triangle gets the root 3 and which special triangle gets the root 2. In your 30, 60, 90 triangle, you have 3 distinct angles, a 30, a 60, and a 90. So that's the one that gets the root 3. In your 45, 45, 90 triangle, you only have 2 distinct angles, right? 45 and 45 are not distinct. That's the same number. And then 90, that's the one that gets the root 2. That's not the reason why it gets a root 3 and a root 2, but it's a little numerical mnemonic, as it were, to help you remember. All right, so do some work with all this. If square roots are not your jam, check out my video on how to simplify square roots. If you don't remember how to rationalize, check that out. If my mentioning the Pythagorean theorem had you scratching your head, check out that video. Consider subscribing to my channel so that you know when I put out a new video. And as always, keep on mathing.